All right, everyone. Before we begin, a few quick notes that you've probably heard several times before. Just a reminder to stop by the Business Hall in Bayside AB during the day and for the welcome reception at 1730 to 1900 tonight. Black Hat Arsenal's always got cool stuff, so check that out in the Palm Foyer on level 3. And make sure you join us for the Pony Awards tonight in Mandalay, BCD at 6:30. Lastly, please put your phone on vibrates and join me in welcoming our speakers.
All right, so we're going to talk about Amazon today. Any Amazon folks in the room, by the way? All right, so my name is Dan Amiga. I'm the co-founder and CTO of Fireglass. Dor is our security research team leader. And this talk is kind of a recap on the research that we've done. So in Fireglass, we're building a secure isolation solution, both on-prem and in the cloud. And part of our design criteria when we do these things in-house is we assume breach, right? So as we built our cloud infrastructure and as we've built our cloud deployment, right, it was very important for us, based on this assumed already breached approach, to see how can we what attackers can do, what they can't do, and kind of like learn about that. And the concept that we had in mind was, I know how many of you guys know about Codespaces. Codespaces was a software as a service company which had to shut down. And the story behind the scenes was that attackers actually got access to the AWS security keys. And these guys didn't want to pay the attackers to leave the account. So they started to stop instances, right? So they started to remove the attacker's credentials. But then the attackers actually spotted that, and they basically terminated every instance in the account, every S3 bucket, everything like that. And these guys couldn't survive, so the domain is for sale. So what we've done actually in Fireglass internally is we have about 25 engineers, and we played hide and seek. So every engineer got access keys to an environment, which we later revoked. And what we did is we interviewed and researched what were the things these guys did in order to stay undetected, to stay persistent in the account, even though the access keys were revoked, and so on. All right, so pretty interesting. So what we're going to talk to you about today is actually the infection phase, what attackers should do or doing in order to survive and persist in the account, remain undetected, stuff like that. Very practical things you can do today. And just a very quick intro for those of you who are not 100% hands-on on AWS. Well, compute as a service, right, where you can spin up compute or storage or YAS resources or PAS resources, databases, and so on. And the interesting point is that everything in AWS can be controlled or automated via an HTTP call, right? So in fact, there's a saying within engineers, within software engineers, that if you're doing things in AWS through the console, you're not doing them the right way. So you should do everything through an API. So because everything is exposed through a public API, right? If someone grabs a hold of the AWS access tokens or access keys, you're in a big trouble. So the way that AWS manages access keys, users, permissions, and policies, and all of the identity management story is via a service that is called IAM, or Identity Access Management. So as an attacker, what I'd like to do is actually try to understand how can I remain in the account even after admins have revoked my credentials in IAM. And then the second service that we're going to look at today is Lateral, which actually audits every HTTP call, every API call you make into AWS. And as an attacker, what I'd like to do is stay undetected. So I don't want my operations to be logged in Lateral. So we'll start with, the first thing that we want to start with is the infection phase. So just to go really quickly over the different things that attackers could do in order to gain access into an AWS account. And we divided this into 3 categories. First would be user fault infection. The second would be AWS-specific infections, and the third would be third-party services. And that's actually, we have some pretty interesting stories for you. So user fault infections, starting with infected machines, either remote access Trojans that was targeted in advance towards AWS admins, right? Or maybe a man in the browser, like a browser extension that starts as a friendly browser extension, but then later transforms into something malicious. There's a lot of helper browser utilities. Plenty of phishing attacks that are targeted towards AWS administrators. So things like your instance is about to be retired in an email, please log into the console, and that leads to a phishing attack. Some of those phishing attacks actually have the AWS SSL certificate because you can host static content on top of S3, right? So you see the same favicon, the same SSL or similar SSL certificate, and there's tons of source code repository errors, right? So you've got your devs actually pushing in code to public repositories. So I've actually been teaching cloud computing for about 6 years to university students. So I thought about, I would say, 1,200 students in the past 4 or 5 years. And source code repository is something that I thought that's only student things, only stuff that you see with education, that they make a mistake. But when we show this presentation, we actually got a lot of feedback. So you should watch out on what's being checked in. A second category of infection is infection through AWS. There has been some talks in Black Hat in the past about things like cloud metadata, right? Cloud RFC. So basically, if you have an application that the attacker could actually convince to make HTTP requests on its behalf, it will actually be able to access the cloud metadata service that's only accessible from your EC2 instance or from your AWS resources. And it's an easy way to get the access keys back. Right? The online presentation tool Prenzy just went through a similar attack. Another topic that's worth mentioning is poisoned AMIs. So as an attacker, I can go ahead and provision an AMI and spin it up as a public AMI and then use some sort of phishing techniques to actually convince admins to spin up an AMI in their environment. The third topic is something very, very interesting. I don't know if you guys know, but there's a lot of, AWS is doing a great work with startups, and one of the things they're doing is they're giving incentive programs. So, for instance, we got like $150K US dollars, right, of credits just to start working on AWS. And the interesting thing with this is that now you have tons of startups or tons of small organizations that by the nature of startups, they either pivot, right, or they close shop. And then what they do is you've got IT admins with $100,000 of credits in AWS, right? So what these guys are doing, it's kind of like a black market, is they're selling it, right? So you can buy an AWS account with $100,000, right, for 20 grand, right? Now the problem is, you just saved a lot of money, but the problem is that there's no reset button in AWS. So if you just purchased an account, right, or for some reason, if you just got access to someone else's account in a very valid way, just transform of ownership, there's no way to actually go ahead and iterate through all of the data centers, all of the different regions, all of the different APIs, and try to remove stuff, right? So you might leave stuff like spot instances that will be later invoked, or SNS notifications in Tokyo, which is a region you forgot to iterate on, right? So account jumping is pretty cool. And the third thing in terms of infection is infection through third-party services. And that's very important to mention, that you're only as secure, right, as your third-party service you're using. And what's interesting with AWS is there's a whole ecosystem around AWS, like application performance and monitoring tools and stuff like that. So as an admin, what I'm going to do is I'm going to give credentials like read-only access keys to companies like Datadog. We're a big fan of Datadog. We're using Datadog. And what happens is if somebody hacks into Datadog, then your keys just leaked out, right? But this is just read-only keys, right? What I want to show you is I want to talk about something else that we've seen, which is we've followed all of the best practices in terms of how to spin up compute in AWS, but we still got our production keys leaked, right? Obviously part of the research. So what happened is in AWS, if you want to spin up a Docker container and you want that Docker container to be stateless, right? Which makes sense. What you do is you create a test definition, and in that AWS test definition, you actually provide the access keys. And you provide those through environment variables. All of this is best practice. What's going to happen is once you spin up a Docker with that test definition, that will be picked up by CloudTrail, right? And CloudTrail will actually log that out and send it to companies like Datadog. And there you go. My environment variables that contained my production access keys are now in Datadog. Now, just to give you a sense of how real this thing is, just a few weeks ago, Datadog just emailed most of their customers, including us, and they go like, you guys have to rotate your keys because we've been hacked. So you're only as secure as the third-party services you're using. So I guess the bottom line is, you should, when you design and work with AWS, you should plan the day after you get breached, right? There's plenty of infection possibilities. The next topic I'd like to talk about is survival from an attacker's perspective. So I just got myself a pair of access tokens, right? I can go ahead and do API calls inside AWS. The question is, what happens, again, I'm an attacker now, what happens if IT just spotted me and they're going to remove my access keys? So what we're going to see is, we're going to see something very interesting that we discovered as part of our research, which is, we're going to show you how we still remain in control in the account, and we're able to do AWS calls even after those access keys are deleted, right? And what we're going to do is we're going to use a service in AWS called STS, or Security Token Service. This manages a lot of the federation, a lot of the temporary session tokens. And what you can do with STS is you can generate a temporary session token. And that actually remains valid after the original token gets deleted. And so let me jump really to a quick little demo. So what I'm going to do is I'm going to work with let me spin up a terminal and go ahead and show you that we're working with a set of credentials in AWS, and we can actually make calls, right? So we can go ahead and do STS get caller identity. That will actually invoke a method over AWS and show us what is the identity. And we're working under David, right? And in a few minutes, right, the organization will actually delete. So I'm going to be this guy. I'm going to delete this guy's credentials. So as an attacker, what I can do is, right, I can actually go ahead and get a session identity and get a session token, right? And I can actually say that this thing would be valid for about 36 hours. So that's my session token. I'm going to jump really quickly to the terminal so you guys can copy it and use it in my account. And what I'm going to do is I'm going to go to do the identity and access management service, and I'm going to go into David, and I'm going to actually delete this guy's credentials. So I'm going to delete the specific access key that I'm using. So now if I go back and I make the same call again, right, I got an error, right, because I'm using the old token. But what I can do is I can actually go ahead and configure my environment, right, to actually use the temporary session token that I got. So I'm going to get the access key here. And I'm going to get the secret access key. And then I'm going to use this temporary session token and I'm going to paste it in here. So it's not something that's actually supported as part of the utility itself, right? Are you following? Am I good? So now what I'm going to do is I'm going to get the caller identity again. Only this time, right, I was actually able to make that API request, although I don't have any access keys anymore. Right? So that's temporary session key, which is not affiliated by Amazon's design with the original security key. So I can do a lot of things here, right? So I can go ahead and let's take a look at what are the instances that are currently running in the account. And remember, from an IT perspective, from the customer perspective, from the account perspective, I no longer have any any credentials whatsoever. So I can go ahead and use the temporary session token to actually see that I have instances running. I can query a lot of things inside the account. There's some stuff that I cannot do with a temporary session token, like if I try to actually list users on the specific IAM account, right? That's going to be challenging if this guy has multi-factor authentication enabled, right? So there's quite some things that I cannot do, but stopping instances, starting instances, S3, a lot of the things in the API stuff that I can do. And then what I could have done also is when I had the original access keys, what I could have done is I could actually create an EC2 instance that assumes a high privileged role that's associated with an instance profile that has permissions, production permissions. And then as an attacker right now, what I can do is I can actually start that instance if it was stopped. I can change the security groups if it was blocked from the outside. And I can always SSH, right, back to an EC2 machine. And then now what I can do is I can do STS get caller identity again. And this time, this guy I'm now running with production role. So I can go ahead and even do stuff like list users, right? And I can go ahead and create administrative permissions and do a lot of things, right? So it's not just about surviving, right? It's also about elevation of privileges and things I can do. So if I do these things really quickly, right, there's a good chance that I can do that before the organization actually understands that that his credentials were stolen. Right. So with that, what I'm going to do is I'm going to pass the mic over to Dor, and Dor is going to show you everything from now on based on this temporary session token. So we shouldn't have any permissions, right, so far, right?
Hi. So now that we know that we can survive key rotational deletion, the next attacker's objective will be to remain undetected, to stay under CloudTrail's radar. So we divided this part of the session into 3 categories. The first is how we can do it by altering CloudTrail directly. The second is how we can do it by altering the S3 bucket where CloudTrail saves its log files. And the third is how we can interfere with the encryption process of the log files. So the obvious way to do it will be simply delete CloudTrail. Or instead of deleting CloudTrail, stop the logging, do whatever you want in the account, and then resume the logging. So when you stop CloudTrail, it stops the logging immediately. It does not give time to the administrator to review the suspicious activity. So even though the administrator might be actively monitoring these 2 API calls, you still don't know what happened in the account. You need to go to every region and do every service within those regions and understand what happened. This is a frustrating job. A more elegant way to do it will be to disable the multi-region option. So only the region where CloudTrail has been configured originally will continue to collect trails, will continue to collect API calls. This is more likely the administrator this is not monitoring, and it might be a good option for an attacker. We can move our efforts to the S3 bucket where CloudTrail saves its log files. So every 5 minutes, CloudTrail saves a log file to S3 bucket with all the API call. We can set up a S3 lifecycle policy so that instead of moving them to Glacier, like to a cheaper storage, we can just delete the files. So the administrator remains with 24 hours of logging. That's it. Although 24 hours is not much, we can come up with a better solution to this problem. We can create an AWS Lambda. For those of you who are not familiar with AWS Lambda, it's a serverless compute that triggers on action in AWS environment. So I can trigger AWS Lambda to give my own code that will be executed when someone adds a file to a bucket. So when Cloudtrail adds a file to a bucket, my AWS Lambda will be triggered and delete the file immediately. So even if someone consumes the bucket, S3 invokes the Lambda directly, and it wins almost every race. And you might say that administrator intrusion detection system is the monthly bill. And you're using Lambda, it might cost money. But the free tier is 1 million requests per month. So even if you use it for a whole month, every 5 minutes to hide your trails, it's remotely from the monthly bill. It's a 10%, even less. So the third way that we come up with, and there are a bunch more ways, you can read about it in our white paper, is to interfere with what Amazon called server-side encryption. They want to protect the file at rest. So when you save a file to an S3 bucket, it encrypts the file just before you save it on the disk, and when you ask for the file, it decrypts it and gives it back to you. You can create your own custom key using key management service of Amazon. And what makes it so powerful is that you can create a policy to this key. And I'm going to show you a demo how we can escape Cloudtrail using this technique. So the first thing we would like to do is to create our custom key. And we will say that the policy of this key is just a policy that no one can encrypt or decrypt the file besides Cloudtrail. So Cloudtrail works completely the same, does not feel any change, because it can encrypt the file or decrypt the file, but the administrator, they have nothing to do with this file. And we don't want them to change the policy. So what we need to do is not to give them the permission to change it, and to say that we know that no one can change the policy. We know that this key becomes unmanageable. But we don't care, we're attackers. So we just say that we know, we agree to the terms. Yeah. Okay, so now we create a key, and we need to associate it with a Cloudtrail. So we take this key, and from now on, this black hat Cloudtrail will encrypt the log files using this KMS key. And the administrator have nothing to do with these log files because he does not have permissions to use this key. He can't decrypt the files. Something else that we can do to build more stealth is to disable the key. We can disable the key and delete the key. And from now on, even Cloudtrail can save files to the bucket, because when he will ask for the key, he will say, I want to save this file to the bucket. The key is disabled. He can't do anything. So from now on, there are no files in the bucket. We can do whatever we want, and then restore everything back as normal. So I want to show you what the administrator see in this case. Because we don't have time to wait 5 minutes every time just to show you this. I made it earlier this morning. This is black at 3. And I'll show you what you see beforehand. You see that there is last log file deliver time. See it right here. The only thing that is going to be missing is this one. That's the only indication that administrator have in the console that something went wrong. And it's only for a few minutes. You just do what you want, wait for the log files to flash, and then you restore everything back to normal. Great. So now we know that if we want, we can escape Cloudtrail. It's not a big deal. There are plenty of ways to do it. The next objective will be to maintain persistence in the account. We're going to talk about 2 kinds of persistency. One is persistency to AWS account, persistent access to the management, to do API calls, to create keys, to do whatever we want. And the second kind of persistency is persistent access to virtual private cloud that the administrator assume that are safe. So what every attacker will do, the first thing that they will try to create new users. So when they will try to create these new users, they don't just create I'm attacker user, they will use the name of an existing user, just kind of typo squatting. And another thing that they were able to do is to use the fact that Amazon allows up to 2 access tokens per user. How convenient for the attacker. So we can iterate over all the existing user and create a second access key. So now you have a bunch of access keys. But the sharp guys here will understand that this is just a merely point-in-time activity. Because if the administrator suspects that something going wrong in his environment, he will delete all the users and create new ones. So in order to solve this problem, we can create an AWS Lambda to save the day. Basically, when someone creates a new user, we can create a Lambda that will be triggered and create an access key to this user and post it back to us. Now we have persistency to future users. Now we have a bunch of access tokens. Some of them might have permissions, some of them might not. And we want to use all these tokens. So we can backdoor roles. We can say that all the roles in the environment can be able to assume by the tokens that we have. So we can take our tokens and assume roles to get more permissions, even though the administrator didn't meant it to be. We can create a Lambda that when it triggered on newly created roles and adds the backdoor to the role. Even if someone updates a role and delete our backdoor, we can create a Lambda that will be triggered again when someone updates a role to reintroduce the deleted roles, the deleted backdoors. So I know what you're all thinking, that Lambda is a very powerful tool and you want to protect it. So what an administrator can do in order to delete our functions? He can use this API call, delete function. But someone can spot something stupid with this API, not stupid, like not smart. It's delete function and not delete functions. So we can create another Lambda that will be triggered when someone calls delete function to reintroduce all the deleted Lambdas. This is great, right? So we can create multiple Lambdas to reintroduce our Lambdas, and we are persistent in the account. To be honest, there are ways to overcome this. You can create policies, it takes a few minutes, and you can overcome this, but we are not going to go easy on the administrators. The last kind of persistence we're going to talk about, Dan will elaborate more about it.
Yeah. You hear me, guys? Can you turn on the mic?
Yeah.
Yeah? All right. So actually, cheers to Dor. It's his first Black Hat. He comes here as a presenter, so cheers, Dor. So last persistency method is actually something very, very interesting. We've been working a lot with large enterprise customers, and what you see in large enterprise customers is that they actually use AWS to extend their existing on-prem data center. And one of the ways to do that is to actually create a virtual private zone or a VPC that has no inbound or outbound traffic, right? So it only has access from within the data center, right? So everything, private IPs, private nets, and so on. But remember when we started the presentation, we talked about that everything in AWS is exposed as a public HTTP endpoint. So what we can actually do is we can take a VPC if we have access to the account, right? So we can take a VPC, right? That VPC is surrounded with security groups and ACLs. There's no inbound or outbound access, right? But what we can do is we can actually inject a Lambda inside that VPC, right? And then by design, right? There's all kinds of endpoints in AWS like the AWS Gateway API, right? That actually triggers a Lambda once you make an HTTP call, and by design, this is exposed to the outside world. So what we can do is we can actually spin up an AWS gateway, right? Invoke stuff from the outside world. That will trigger a Lambda inside the VPC, right? Because the gateway to the Lambda is AWS specific stuff, right? That will actually trigger something, right, in an environment that's not even supposed to be exposed from the outside world, right? So plenty of options there, and even if you use the right security groups, the right mechanisms, that's still an issue. We've got to summarize. I like to talk about the lateral movement capabilities inside AWS. So it's not just about the fact that if there's access into the account, someone can stop EC2 instances or containers. It's not just about data leakage where you can make sure you're encrypting your instances or you're encrypting your SQL or NoSQL data and so on. It's also about lateral movement back to the data center, right? Because of that direct connectivity. And there's also some other very funny things that you can do. So obviously, you can go ahead and provision users. You can go and do some privilege escalations. But you could also actually control Amazon support tickets. So you can do via the API, right? So there's a lot of interesting things you can do there in terms of combo social engineering and lateral movement, right? So there's a lot of things there. And when you think about the stuff that we talked about, because of the variety of services and regions, right, and the complexity of the policy, for an IT guy, right, to be able to control all of that, very challenging. And if you miss a certain point, it's pretty easy then. The effect is just so dramatic. I think we pitched that to we showed this presentation about 20 AWS IT guys, and they were all, well, this is interesting. We didn't think about that. So the last question is, I mean, what can you do? Right? I mean, what are the next steps and what can you do? And as always, especially with a platform like AWS, the devil is in the details, right? So when you're using a service, right, you should really take care of understanding post-bridge methodology, right? What do you do, right? Pay careful attention to CloudTrail and all of the different CloudWatch and notifications you want to set up, right? In case someone messes up with that. So that's one. The second would be, as always, you should plan your environment, as your architecture as a stateless architecture, where you focus on your data, right? So make sure the data is encrypted. Make sure that if the data is stolen, right, there's no way to actually decrypt that. And assume that your environment could be teared down to pieces, like what happened to code spaces. So what you want to do next is you want to make sure that everything in your environment is automated via code or recipes, right? So in case an account has been breached, you'd even have the capability to create a new account, associate a new credit card with this guy, shut down the old account, change the DNS, and use the code and the recipes to just provision the environment from scratch, right? So you have the confidence that on a breach incident, right, you can still go ahead and keep on production. And then I would say the last point is to leverage strong account separation. So that's something that we've seen a lot of best practices around. So don't put everything in the same account. But we see a lot of companies doing account separations between dev, staging, and production and stuff like that. And then just or maybe production 1 and production 2 for A/B testing and stuff like that, and they do some sort of Route 53 DNS games, right? So they weighted average to weighted formulas. But we're talking about a much stronger level of separation. So you should even consider separating based on services, not microservices, but higher level services might be separated. So if your account was breached, right? You just narrowed it down to a very specific subset. The last point would be that even if you do strong account separation, right, there's also the capability in IAM to actually assume roles from another account, and we're planning to talk about that next year in Black Hat, right? So, and depending on the score eval that you guys give us. So with that in mind, again, we'd like to thank everyone for for coming. We're hoping it was valuable for you guys. And if you have any questions, we'll be staying here and taking any questions. Okay.